So we can make amines, but what do amines do? Well, of course, we've already talked about extensively their bases, and so they can react with acids. I haven't gone into depth on that because by now I trust you can talk about acids reacting with bases for the neutralization reactions. We've also shown extensively that amines are nucleophiles. They can react with halogenoalkanes to give a messy mixer product via nucleophilic substitution, and of course I mentioned that earlier on. We've just seen them reacting with the acid halides to give amides, again, nucleophilic substitution. So we talked about two of the reactions of amines acting as nucleophiles. We also saw the best, easiest amine, ammonia, reacting with carbonyl compounds. Well, in the same way that ammonia can react with carbonyl compounds via nucleophilic addition, so can amines. So it's worth spending a slide just expanding that a bit. So here's our typical carbonyl compound reacting with amine, as we said, with ammonia, gives us an imine. We can get the same type of reaction if instead of using ammonia, we use a primary amine. Okay, so again, we see an imine down here, that carbon-nitrogen double bond. Now, if you think about what's effectively gone on, and I'm not going into the mechanism because it gets all kinds of weird and messy, but what you've effectively lost is you've lost an oxygen and two hydrogens, which is, of course, water. Okay, down here for this primary amine, we've lost the oxygen from the carbonyl compound, the two hydrogens from the primary amine, losing again water. So ammonia, or a primary amine, reacted with a carbonyl compound gives you an imine, and then of course we saw earlier you can reduce imines quite happily to get to amines. When you react a carbonyl compound, however, with a secondary amine, then you make a different type of species called an enamine, that you have the carbon-carbon double bond, that's the N, and then of course up here you have an amine. So this is a way to make a tertiary amine that's got a carbon-carbon double bond in it next to the amine group. Again, you can see where this comes from because again, water is the other product. There's the oxygen for the water, there's one of the hydrogens for the water, but now the second hydrogen from the water comes from this carbon here, and so that's why you get the double bond in there. Again, the mechanism way past what I want to do in the A level, but just notice that amines as nucleophiles, they can do nucleophilic substitution either with a straightforward halogenoalkanes, they can do acyl nucleophilic substitution, we've already seen that, producing amides, primary, secondary and tertiary amides, but you can also make these fun compounds that of course you can then go ahead and reduce quite happily when you react amines with carbonyl compounds.